So here's a board exercise on generalized Ohm system again. So let me just give you some of these examples. So let's say there's a mass M, and we for linear translation system, we give a force. Then we know that this mass will be changed into another location, and that will be X. Then what would be the the energy or work is, we know that F times delta X. Let's say this is delta X. And the power will be this work divided by X, or F delta X delta T equals F times V. So that's how we know as a translational system. And for in terms of a rotational system, that let's say there's a hinge and or a wheel, and we have this mass over here, and we have to give a force as a let's say like this force, and this is the arm length of R. Then what happens with this force giving as a torque? So that effort as a torque as a tau, it can be defined by F times R. And then as a result, there's a rotation happens like this. And that now, the change will be resulting in delta theta. So then the work now is the torque times resulting delta theta. And then what's power? Like this happens in the wheel or bicycle or a car, whichever using a wheel or airplane engines. So in that, power is now the tau times delta theta over delta t, or tau times omega, which is angular speed. Okay, does it make sense? And the hydraulic dynamic system, we can say, let's say has a this sum of the volume here. Let's say in this fluid system, so there's a pressure, like there's a let's gas or molecule or water, there's a pressure. Okay, so that is a driving effort. And then what let's say this membrane, this pressure gives a change into the membrane. So that will result in delta volume, let me say like this. So the driving effort leads to the work as pressure times change of volume. And so the power for this dynamic change will be pressure times volumetric times of volume change over time is pressure times so-called this Q, flow rate. Let's write down as a flow rate. Does it make sense? And of course, electric car system, let's say there's a position as potential 1 and position as potential 2. Let's say the charge like Q, electrical charge like Q, and that charge is against this, it moves to the another position by this electrical potential difference, or there's a will be electric field. Then what would be work is that potential change, so that's delta V, potential change, okay, times displacement now as the change is the Q, and the power will be delta V times Q delta T. Sorry, this is delta, I write it delta Q, and delta as the V as defined as V1 minus V2. then that will be V times current. So this is current. So then how to define as a impedance? So which is impedance, then impedance, let's say just generalized R. So generalized R is defined as driving effort divided by the flow rate of change. So that's defined by V over flow change. So which we know, which reminds us that V equals IR. So that's kind of typical Ohm's law. So like similarly in hydraulic system, generalized impedance can be defined as this driving effort divided by the current, which is Q. Okay, so and the rotational system, the generalized impedance can be defined by the driving effort as torque divided by angular speed or angular velocity. And then in dynamic translational system, we can define impedance or kind of resistance or more like drag in translational system that can be defined as force divided by the velocity. So that defines as a generalized impedance or generalized Ohm's law. And I hope this one will give you some idea and about you extending your idea about a dynamic system in various forms of energy and the representation in real engineering system. Okay, thank you for your attention.